Alright guys, so still not in the classroom with you all. Leaving more videos. Just want to give you a quick little timeline of what's going to happen here today, Monday. You all have a video. On Tuesday, tomorrow, you'll also have a video. And pretty much every day you're going to have a video. But what I want to explain here is, here you're going to have the assignment, which you're going to turn in on that day. And you're also going to have the review. So you are testing this week on Friday. Guys, please just be here. You're going to be testing. So review on Friday. Excuse me, review is due Friday. Okay, Wednesday. Again, I'm going to leave you a video, but I'm also gonna leave you just do the review. Don't even worry anymore about any more assignments. Just do the review. I'll tell you which ones to start with first, but get that started. Thursday, the same thing. Video with a review. And guys, I mean the videos, all of them, they're gonna be shown in class. Guys, I mean, since I'm not even gonna be in the classroom anyway, you can start looking at the other videos. Start going through the entire review, especially on Tuesday when you get it. All the videos are already up on the classroom, and they're also on YouTube, so just start looking at them. And on Friday is the exam. This is Unit 10, by the way. Okay, so I'm not gonna be in the classroom next week anyway either, and so I'm just going to go ahead and give you the test on Friday, see how it goes, because I can't really even push it to the following week. That's when all the AP tests are going on, and I'd rather that you guys concentrate on the AP tests next week than on mine. So they are more important, and we'll get back on it, and we'll start to review again once all this stuff is over and once I'm back in the classroom. So I wanted to give you a quick review on that. And I mean, today's lesson is a pretty simple one. I'm going to go through some stuff here with y'all. So today's lesson's over continuity. So really not a big concept. It's just, do we have something continuous? And I know the packet that you have has like a bunch of pages. We're not going through all of them. Don't worry about it. Really only going through half, and I'm going to show you what I need you to know about those. Okay, so continuity, guys, I mean, let's look at some graphs here. It just means if they are broken or not broken. And so if I follow this line from here to there, not broken. Okay, and right here I see that it has an open dot, and that's where it breaks. So here, remember, I'm just looking, and this is not a new concept. From A to C is where it's continuous. So from A to C, if I write it like that, that's continuous, right? And from here to there, I start again at C, and I'm continuous until I get to this point, which is B. So also from C to B, I'm continuous. Okay, so not a new concept. Same thing here. So all I'm doing here is following along. So from here, from A to, well, here I say A to C again, I'm continuous. And then here I have a different type of break, but still a break. And so again, I start continuous from C to B. Okay, and I'm gonna see the same thing here. So from A to C, continuous. Again, this is a different type of break, and we'll talk about those in a little bit. And from C to B, it's continuous again. So not a new concept, not a hard concept. Again, you're really just gonna be looking at graphs today. So as I start to look at these right here, these examples, I'm asking, determine the types of discontinuities and the intervals where it's continuous. So right now, we're just going to concentrate on this one, because we'll come back to these right now. Because I haven't told you what those discontinuities are called. So like right here, you see how I jumped? That's discontinuous right there. And we'll talk about those right now. So don't worry about that part right now. Okay? So for part B, where I'm asking for intervals where I am continuous, so here, notice that this has an arrow, so this is going in the x direction all the way to negative infinity. Okay? And it's continuous until I get to this point right here, which I call negative 2. And from here, again, the graph picks up starting at negative 2, and it's continuous until, well, I have an arrow here. So I'm going to assume that these x values keep moving in this direction all the way up to infinity. So that is where it is continuous, guys. Okay, so same thing here. This one's a little bit harder. So all the way over here, negative infinity is, because this is an arrow, and it's continuous. I have to keep falling, continuous. And I get to this point right here, which in the x direction is negative 4. And then I go from negative 4, right? It's continuous. Well, here I have an asymptote, so the graph will never come over this point, at least on this side of the graph. So I'm going to assume it stops right there from negative 4 all the way to negative 3, because it won't cross this vertical. And from here, it's going to be from negative 3 all the way to positive infinity. So again, not a new concept, and we're going to continue from here. So right here, guys, this is a new concept here. So we're going to deal with limits again, and there's something a little different from here from limits than what you've seen before. So I've always told you that it's the y value. Now we really haven't dealt with any cases where, what if the y value is different on both sides of the number? Okay, so here what I'm asking is, what this little plus sign and minus sign means, what is the limit from the positive side and what is the limit from the negative side? Okay, that's what the minus sign means. Okay, so what I'm saying here, determine the limit as x approaches c from either side. Okay, so this is really what I'm looking for. The limit as x approaches, in this case c is negative 2, from the plus side. So if I look at my problem here, let's go to negative 2. That's where I see the break. So the positive side, guys, I mean, if I drew this vertical line here, the positive side is going to be anything on this side, right, in the positive direction. So this is the positive side, and over here is the negative side. So I really should have put those the other way just so you can see them. But if I'm looking at it from the positive side, so let's look at the graph. I'm following it. I get to x equals negative 2 right here. Well, the limit is the y value. So here the y value is 0. So that's my limit. My limit from the negative side, so remember I have a little break here, so the negative side of this line is over here. So if I were to follow this graph here at the negative, well, look, this is where the graph stops, on the negative side, and the y value is negative 3. So if I follow this from the positive side, I get a different y value, right, on this side. If I follow it from the negative side, I get a different y value, this one right here. So I can have two different limits for the same graph. Now, if I had just asked for the entire thing, so if it just said from negative 2 with no little plus sign or minus sign up here in the corner, well, then I'm asking for the total value. And if I can see this right here, these are two different numbers. They are not equal. Right, 0 is not equal to negative 3. So if you don't have a little plus sign, a minus sign here, well, then you say that your limit does not exist. And I know for some of the periods I went ahead and told you that before. Limit does not exist in this point, okay? Because these two are not the same. If they were the same, like we're going to see over here, I think. Yeah. So I'm going to do it from the plus and the minus side. Okay. And for the whole thing, let's look at it here. So at negative 4, I'm going to draw a line. I'm drawing it right here. So here's the negative 4. And so if I'm looking at it, again, this over here, this side, this is the plus, and these are the minus values. And if I follow the graph right here, the plus, on the plus side, I see that my y value is positive 1. So from the plus side is positive 1. Over here on the negative side, so I'm going to follow the graph till I get to this line. I see that it's also positive 1. And now, since these both are equal to each other, then I say that I do have a limit for the whole thing, and it's positive 1. So when they're the same, the limit is for the whole thing is just what you got for these two. But when they're different, you say it does not exist. So that's pretty much the big thing about today. So one more thing here is removable and non-removable discontinuity. So those are the only two categories we're going to deal with. So right here, if I look at these, just be careful with these. This is a removable one. This is non-removable. So when I see a big jump, it's non-removable. When I see that, again, I see just like a little open dot here, that's removable. Okay, so that's all we have for that. So if I want to go back to the other problems, right here, when I ask for what type of discontinuities, so I see that there's a real big jump. Let me open up the other one just so you can see it. There's a real big jump, which that means it's non-removable. So what kind of, I have a non-removable discontinuity here. And for this one, at least at 4, right here at 4, I see that it's just like this one right here, which is removable. So what type of discontinuity did I have here? Removable. Okay, so that's the end of the lesson, guys. I'm going to go through one of the homework problems with y'all just so you're not confused, because it kind of looks a little messy. So what I'm asking here is, and go ahead and make these changes. Determine the type of discontinuity, so like what we just found, removable or non-removable. That's what I'm asking for. Determine the intervals where it's continuous, so like what we did in the first one, and determine if this statement is true, if the limit on the plus side is the same as the limit on the negative side. So, oops, I made a mistake here. So, what I'm asking for part A, right here, I see that this is a jump, and we know that a jump is a non-removable discontinuity. Okay, like we just finished seeing right here. Looks kind of like this one right here, non-removable. Okay. Part B is where it's continuous. So I'm going to write it down here because I made a mistake here. Okay, so part B, where it's continuous. So right here, I'm looking at it. In the x direction, this is an arrow, right? So it goes from negative infinity all the way to this point right here. So in the x direction, it is 4. And then I see that the graph picks up again, 4 all the way to, well, I'm going to assume that this keeps moving in this direction also, so 4 to infinity. Okay, and for my discontinuities here, guys, excuse me, for my limits, so again, I have one from the positive side, one from the negative side, so I wanted it at 4. Again, this is the plus, and this is the, well, let me not put it here. This is the plus side, and this is the negative. So on the plus side, I see that the y value here is at 0. And on the negative side, I see that it is at negative 3. Okay, again, plus side right here, y value is 0. From the negative side on this side, it is at negative 3. So is this statement true? Are they the same on the positive and the negative side? So here, they're not true, which I can say that the limit does not exist. Okay, it's not a, this is a D here. So that is today's lesson, guys. Please try hard. I know it sucks that I'm not in the classroom with y'all, and I really do. I wish I was there with you. But you guys got to push and try to get through the lessons, and I will talk to you all when I see you in the hallways, and just keep going, guys.